Start recording. Okay, IPv6 subnetting.
Yes.
All right, let's do it. I'll tell you what, let's do it in the context of an actual network. Okay, we'll use a 2911 because that's what we have in our lab. And we'll just put two hosts over here. And let's put a server out here. And again, we're talking about IPv6 subnetting. So we'll do two subnets. This will be on a subnet, and this will be on a subnet. And this whole thing will be an IPv6. 2000 colon AAA colon /64. Should be 4 A's in there. Which really is 2000 colon AAAA colon all right, these are the same thing. We're going to do our subnetting in here. Okay. So our configuration for the router will have to account for that. We're going to have two subnets. This is going to be 2000 colon this will be subnet 1 /64. Okay, so we're subnetting using the fourth hexbit, using the same notation that I typically use. On this side, I'll give you the router information. On that side, I'll give you the PC's information. We're going to do all static addressing right now. PC is going to get ::5. The router is going to use G00, and it's going to get ::1, ::5. G01, and then we use G02 out here. And this would be a different network, 2001 /126. And this is just a point-to-point link. It'll be 2001 ::1. And the server will get ::A for 10. And we're using G02 on the router. All right. By the way, another thing that we'll get to see here, we talked about sockets. We'll get to look at an IPv6 socket. Enable conft host name R0 no IP domain lookup IPv6 unicast G00 IPv6 address. It'll get 2000 ::0 :1. We're in the :1 subnet, :1 /64. Okay, no shut. And now interface G01 IPv6 address gets 2000 the :2 subnet ::1 /64. No shut. Interface G02 gets IPv6 address 2001 ::1, and it's a /126. no shut. And so now we've configured all three interfaces. Exit. Notice this is all static addressing. Let's configure this router. No. Okay, I don't see any errors. I think we're good to go. We just have to connect it all now. Connect to G01 here. Connect to G00 here. Connect to G02 here. We need to configure this server. Static. It's 2001 : A, and it's a /126. Its gateway is 2001 : 1. I have a DNS server configured here. All right. This PC 0 gets a static IPv6 address of 2000 : we're on the :1 subnet 5/64. Its gateway is :1. We haven't put in a DNS server. We don't have any ports left to do that. And then this PC here, PC1, gets 2000, the :2 address space, subnet 64. The default gateway, :1, and again, no DNS server. So I think we're configured. Let's fast forward time. Let's see if we can access this server. Now remember what I mentioned earlier. If you don't give it a subpage, if you just give it the URL or the IPv6 address or IP address, it's looking for index.html. So let's go into the server first. Services, HTTP, index.html, edit. So you can see that this is what we're getting to. I'm going to just make it bigger, and I'm going to change it to red. Okay. Save, and then kill the X. Hit the red X after you save it. Now let's go to 2001 : A. :A. Okay, this is good. We have a problem. It's not working. Request timed out. So let's see if we can ping our router first at 2000. Okay, can we ping 2000 : yes, we can ping our router. Can the server, can it ping its default gateway? No. Wonder why. Let's do a show IPv6 interface brief. Show IPv6 interface brief. Show IPv6 route. We're on PC 0, and let's try to ping that server at 2001 : A. Destination host unreachable. We didn't get that last time. It's good to see that. What does destination host unreachable tell us? Anybody?
IP route.
Destination host unreachable means it got to the router, but the router doesn't know what to do with it, which means the router doesn't know anything about 2001 : A. And it should via this interface. because we put an A in that last hexbit. That's why. It's 126. It's got to be 124 if that's an A. So they don't match up. Let's find out why. This needs to be, I'll do it in the packet tracer. Okay, so what I did is I made it a /26, but this is A. A is how many bits? It's 4. This is a 126. It has to be 124. 2001 : 1/124 gives us all 4 low order bits in the last hexbit, the 8th hexbit. 2001 : A/124, that gives us in the 4th octet. So we need those 4 bits. Okay, so that'll fix that. So this has got to be a 124. And we got to make this a 124. Now, interestingly enough, we've got to remove, with IPv4 you can overwrite an address. With IPv6 you got to remove it and reconfigure it. So I'm going to copy this, I'm going to go into this router, conft interface G0, oops, interface G02, no IPv6 address, and shut it down. And then we'll put in what we just copied. IPv6 124, no shut. Alrighty. And now we also have to change the mask over here on the server. It should be a 124. Don't forget that. This would be K, week 11, IPv6. Alright, so this server is configured with a 24. This router is configured with a 24 on that network. Let's see how we make out. Now we get a response. We've demonstrated, well, let's go do the one thing that we originally set out to do, is just go to that web page, which is, oh, actually we're just giving it the URL, I mean the address, 2001 : A. There it is. All right, same thing from here. So we got it up on 2 machines. And this, by the way, folks, is, I tell folks to leave things up in class, and that's the essence of the internet. We can access the same resource multiple times. All right. Okay, again, the purpose of this network was to demonstrate basic IPv6 addressing and subnetting, and we also demonstrated the use of the show IPv6 routing table, and we can see that every entry in an IPv6 routing table is an ultimate route. We don't have to deal with IPv4 where sometimes you have parent routes and you have ultimate routes underneath the parent routes. And also show IPv6 interface brief. Okay. All right, so we showed these 2 networks. This is a summary of IPv6. Thank you, David, for asking about that. We did not show the use of the DNS here. It's very similar. We could put a server in here, put a switch and a DNS server in here that would give us access to a DNS, and we could put this, give this a URL. Does anybody want to see that? Because you do have to know that, not from what I give you, but from what Neticat is going to ask. Or is everybody good with configuring a DNS server in terms of packet tracer?
Little question.
Yes.
How 124 is translated into 1010?
Ask the question again.
2001 :A / 124
Yeah.
with 1.1010
Yeah, this is
is very,
just the fourth octet.
oh,
This is the fourth octet in binary.
okay.
Yeah. So I guess what I should do here is, I mean, I said fourth octet, the eighth hextet. Eighth hextet binary. Okay.
Thank you.
Yep.
But also it is the this concept of subnetting in the course chapter 8.
Yeah.
There we were talking about subnet ID. We were using the subnet ID exactly.
Yeah. Well, I did 1 and 2 just now.
Okay.
So the
So
subnet ID is what's in the fourth hextet.
it was a little confusing for me because that means that we can have how many subnets there?
2 to the 16th, because this is 16 bits. Remember, these are all hexadecimal values. So you have 2 to the 16th subnets, which is a lot.
Each one of them will have 65,000 hosts.
Yes. Possible values, yeah. So here, subnets 13 through 65534 are not shown.
Okay. Thank you.
Okay. Good question. Good question. Folks, in terms of IPv6, I'm just going to ask you anything that was on that the videos I posted last week. Certainly you would be responsible for them, but it's all from Netacad. We have IPv6. We at the where did they talk about DHCP unicast? Yeah, the Slack, the use of Slack, as they talk about it in section 7.2.4. This is spelled out in those two videos, I think, pretty well. And they're fairly short, but you get Slack, which is when all the options are turned off. And then you get Slack with stateless DHCP, which is when you turn on the other option, which we talked about last week, and stateful DHCP, which I told you last week does not work in Packet Tracer, where you turn on the managed option. Okay. right, so let's talk about what next week is going to look like. All right, so I'm going to stop this recording.